Artificial intelligence is already everywhere. It is so deeply integrated into our daily lives that we often do not even notice it. It suggests which movie to watch, enhances the photos on your smartphone, selects the best route through traffic, and much more. AI is like a digital brain. It can learn, reason, solve problems, and make decisions, just as we do, but with far greater speed and computational power. Take Bob, for example. He has discovered how much artificial intelligence can simplify his life. At work, it helps him write more effective emails. At home, it manages his lights and security systems. And even at dinner, it suggests recipes based on his tastes and what he has available in the fridge. The first thing to understand is that artificial intelligence is not born intelligent. It becomes intelligent by learning, and to learn, it needs data. You can imagine data as a gigantic library filled with books, images, audio recordings, numbers, and information. Each piece of data is like a building block of knowledge that AI analyzes in order to understand the world. Let's take a simple example. If we want to teach AI what a cat is, we cannot simply explain it with words. We need to provide it with thousands or even millions of cat images, followed by dogs, horses, birds, and so on. In this way, AI learns the concept of a cat and distinguishes it from other animals through their differences. AI behaves exactly like we do when learning something new. It observes examples and recognizes patterns. And just like us, the more varied and numerous the experiences, the greater its competence in that subject. Machine learning is the method through which artificial intelligence studies and learns from data. It does this by searching for patterns and correlations in the data it is given. The goal is to predict future outcomes or make decisions, while gradually reducing the gap between what was predicted and what actually happens. There are several learning techniques, but the main ones are supervised learning. Here, AI is trained with pre-classified examples. For instance, it receives a large collection of emails labeled as spam or not spam, so that it can learn to recognize them on its own. Unsupervised learning. In this case, AI does not receive labels. It is given raw data and independently finds connections and hidden patterns within it. Let's look at a simple example with Bob. He is sitting on his couch, ready to relax with some streaming content. The system analyzes his viewing history, learns from his preferences, and compares them with those of similar users. In just a few seconds, AI suggests the shows and movies it thinks he will enjoy the most. Deep learning is an advanced form of machine learning that allows artificial intelligence to go further and achieve far more complex results. This technology is based on artificial neural networks, structures loosely inspired by the human brain, composed of layers of interconnected digital neurons. Each neuron processes a small piece of information and passes it to the next layer, which refines it further. When a neural network contains a very large number of these layers, we call it deep learning, enabling AI to detect extremely complex and hidden patterns within data. There are also specialized types of neural networks designed for different tasks. CNNs, convolutional neural networks, perfect for analyzing and recognizing images. RNNs, recurrent neural networks, suited to handle sequences such as text or audio recordings. Transformers, like BERT or GPT, exceptional at understanding and generating natural language, forming the foundation of modern chatbots. Natural language processing, commonly referred to as NLP, is one of the most fascinating applications of artificial intelligence. NLP is what makes dialogue between humans and machines possible. This technology enables computers to understand, interpret, and generate human language, both written and spoken. To achieve this, AI transforms words into numerical representations, then analyzes sentence structures, identifies key terms, and strives to grasp the context through techniques such as tokenization, breaking text into words or sentences. PAOS tagging, part of speech, recognizing the grammatical role of each word. Syntactic parsing, analyzing the structure of sentences. AI goes even further, attempting to interpret the user's ultimate intention and even the emotional tone of a message through sentiment analysis, allowing it to respond appropriately and naturally. Visual AI, or computer vision, is capable of analyzing and interpreting images and videos by reading the pixels that compose them. It converts these pixels into numerical matrices and applies algorithms to attempt to recognize objects, faces, and movements. The most powerful and advanced techniques rely on convolutional neural networks, CNNs, trained on massive image datasets. These networks excel at detecting visual patterns, shapes, colors, and textures. The goal is straightforward. AI should be able to recognize a cat if there is indeed a cat within the image.